Namaste students. Today I am going to teach you subject General Science. In General Science we will study chapter number 15 Sound. Here first activity. Take 6 to 7 glass cups, arrange them in a line and fill them with water with gradually increasing water level from one end to other. Take a pencil and strike the cups subsequently. The sound generated by each cup will be different. Why it is so? When a cup is struck, waves are set up in the air column above the water level in the cup. The frequency of the generated wave depends on the height of the air column inside the glass cup. Since the water level is in each glass is different, the height of the air column in each glass is also different. Therefore, the frequency of sound generated by each glass cup will also be different. So, the sound generated is a different. An app for measurement of sound frequency may be used in ICT. Download videos of Jalataranga from YouTube and send them to your friends by email. Try this available on cell phones. With the help of your teacher, use the application for measure the frequency of the sound generated from each glass cup. Do you observe any relation between the frequency of generated sound and the height of the air column in the glass cup? This is your simple Jalataranga. Can you this experiment be performed with stainless steel pots with a different size? Sound and music. From the above activity, it is clear that if the frequency of sound wave is changed, different sound is produced. Sound waves of different frequencies produce different sound notes. In the field of music, various musical instruments are used for creation of sound notes. This includes instruments like sitar, violin, guitar, which use a string for production of sound. An instrument like a flute, shahnai, which use air blown into pipes for the production of sound. In string-based instrument, the frequency of vibration of a string is changed by changing the tension of the string and or by changing the vibration length of the string using finger. This results the generation of different notes. Generation of different notes. In musical instrument like a flute, the holes of the flute are opened or closed by to change the length of vibrating air column in the flute. The frequency of waves therefore changes and it results in the production of different notes. In flute, different notes can be generated by changing the way of air blowing also. Sound produced by human. Either speak a little loudly or sing a song or produce humming sound like a bee and put your finger on your throat. Do you feel some vibrations? In the human, sound is produced the larynx. While swallowing food, we can feel with our fingers a hard bump that seems to move. This is nothing but larynx. As shown in figure 15.5, it is the upper end of the windpipe. Two vocal cords are stretched across the vocal box or larynx in such a way that it leaves a narrow slit between them for the passage of air. See this figure. Here, epiglottis, a flap that closes air tract during swallowing. Vocal cord. This is a vocal cord. Trachea, esophagus. When the lungs force air through the slit. The vocal cord vibrates, producing sound. Muscle attached to the vocal cord can make the cord tight or loose. When the vocal cord are tight and thin, the type of quality of voice is different. Take two rubber strips out of an unused bicycle tube. Place these two pipes on one above the other and stretch them up tight. Now blow air through the gap between them. As the air blows through the gap between the rubber strips, a sound is produced. Human larynx verse is a similar way. Produce a sound boo, just like a dog barking, and mau mau, just like a meowing cat. Carefully notice the tension of the vocal cord when you produce these sounds. Do you feel that the tension of vocal cords changes when you produce these two different sounds? Sound generated by loudspeaker. You know that sound can be produced using loudspeaker. The internal argument of loudspeaker is shown in the form of cross-sectional view in figure 15.6. It consists of permanent magnet, a coil, it winds around it, and if the current flows through, through this coil, it also generates magnetic field. This you have learned in earlier chapter in this book. This is a figure of speaker which is used in loudspeaker. You must have seen that if two magnets are brought near each other, they move depending on their positions. In the same way, here, depending on the magnetic field created due to coil, the coil moves back and forth. The frequency and amplitude of the movement of the coil depends upon the vibration in the current flowing through the coil. As the coil moves, the conical screen of the loudspeaker which attached to the coil also moves back and forth. Thanks for watching this video.